So this is our tank setting. In the lab, we have a plexiglass tank about 80 centimeters long. And in this experiment, we use a separator to separate tap water from a saline solution, which is marked with dye. Okay, so let's go over to the tank. Here you can see the tank. Okay, here's the separator. Okay, and this is how we do. Okay, this is how we do it, and we use different saline solutions, which means we prepare saline solutions with a certain amount of dissolved salt. Okay, you prepare the solution, you add the dye, you fill the tank, and then you remove the separator. And what you do in that experiment is actually you work out the speed of these flows. Again, very similar to the first experiment, okay, the dam break experiment, but here it's a density-driven flow. How long does it take for the flow to move across the tank? What is the speed of this flow? Okay, does the speed of this flow depend on the salinity, the salt concentration of your solution? Does it depend on the height of the watercolor? Okay, and I can show you one of the previous experiments. Let's get going here. Next, this is how the setting looks like. You can see on the right side is the blue dye, the saline solution. Okay, and this is just the start of the experiment when the separator is going to be removed. So that's the exciting part of it. Okay. On the left side, you'll see that there is a timer, a stop timer, and to measure the time. But okay, here we go in real time. All right, let's go. You see this plume of water moving along the bottom, bouncing against the other side and up and back. Okay, this is one example of a density-driven flow in a tank. Okay, this is how your experiments will look like. But there's also other features that you'll see. You see a little bit of turbulent elements, waves that break, internal waves. And I just want to briefly mention these type of instabilities and how they are created.